think that need to be full.
It's recording now.
Is it? Yeah. Okay. All right, folks, we are just a second. We don't need camera. It is recording our session, isn't it? Okay. Oh, so the virtual learners should be there. Okay, folks. Today we are going to talk about the boil-off gas management. You engineers, you will understand this more better than anyone else, of course, apart from our naval architect and other deckies friends. So what I will request you that just tell us what. If you have any question, feel free to ask. But whenever you are asking, you just say your name. Okay? It is better because then we'll be recognizing, and also our virtual learners will be recognizing more about you that who was asking which question. Okay? So boil-off gas management is one of the key things on board the ship. Most of the vessels nowadays running around are using the dual fuel engines. They could be Solar, their Wärtsilä dual fuel engine and all that kind of thing. We are also consuming the LNG in the boiler for generating heat or whatever. So you already know LNG is methane. It is a lightest fuel. The density is less than 0.5, very light, and it is clear, odorless gas. So what is boiled off? The tanks which are designed, you will do an exercise after that on the simulator about the boil-off gas management, and I'll show you that, and you will also practice that. Boil-off is the vapors created due to the ambient heat input. Okay, the tanks, although they are insulated, but of course no insulation is 100% perfect. So there will be an ingress of heat in the tank, and that ingress of heat is going to let the LNG boil off. Mind that we carry LNG on just the boiling temperature, like 100 degree of water. If you introduce little heat to it, it will start evaporating. So because why we don't carry at minus 170 or minus 180? Because it will be more energy, more input. We'll have to learn. Yesterday you have learned about entropy, enthalpy, and all that. Latent heat of vaporization and all that. I don't need to teach all that again. So you know that. So boil off is inherent to the shortage of cryogenic due to the heat input from the ambient. So these cryogenic tanks, although they are very well insulated, but they take the heat input. And of course the vapor created, that vapor creates the pressure. Okay? Mk3 type, membrane type ship or NO96, they are not designed to type A, type B ship to sustain a very high level of pressures. So their pressures will technically be, we'll have to raise the pressure. The thickness of the tank itself, a membrane tank, it is 0.7 to 1.4 millimeter. So just think about the 1.4 millimeter or 0.7 of a millimeter. It is like a cardboard is even more thicker than that. Okay, so this is what we are talking about. So for LNG propelled ship, the boil-off vapors are usually fed to the ship's boiler, via a compressor and a heater for use as a fuel on main ship engine. Okay, so now you already know that whenever we are in loaded condition, we have a boil off and we use it. Sometimes we do not have a boil off. So we start the small pump, hmm, we pump it out, we boil it off, and then we consume it in the engine room. But normally, when the ship is in ballast condition, we do not discharge all the cargo. We keep the heel, heel, a very little amount of liquid. And that little amount of liquid is technically uh, the coolant of the tank. Whatever heat energy is coming to the tank, that heat energy is heating the cargo and it is getting evaporated. That evaporated molecules or moles, we call them, we take it out. We take it out and we burn it in our engine. So we don't need to heat them too much, and of course, we are not also uh, putting a lot of effort into that, and that work as a refrigerant, because now my tanks are always kept in a condition of minus 161 or minus 162 degree temperature, if not precise, maybe around that. So this is boil off. Um, um, while we are talking about boil off, many of the tanks will have uh, um, on the bunker barge, because we are particularly talk about the bunker barges. Many of the bunker barges has got the pressure tanks, the bullet type tanks, type sheet, and those tanks, um, if they catch fire, or if they are heated too much, the insulation is so good, normally this thing doesn't highly likely to happen. But if it is engulfed in a fire or heat or something like that, the valve or vapor explosion, which may result from catastrophic failure from the tank structure, which was containing cargo liquid above the boiling point at a normal atmospheric pressure. So this could happen on that, but the systems are designed for pressure, and it does not happen when initially you are heating it, but when there is less liquid remaining, because all the liquid will go off from the pressure release valve and they will be burned. But when there is very little liquid left, there is a possibility of that fire going back into that and give an explosion. We call it BLAVI, which is boiling liquid expanding vapor explosion. Okay, this is one of the hazards in our pressure tanks or the tanks, which especially on the bunker barge. But so many technically safety measures are taken that it is highly unlikely that this thing will happen on board the ships. So now, so far we do not have 100% perfect insulation. In fact, what I will do is I will show you a short video on, BLAVI. Just bear with me for 2 seconds. Um, watch this. Okay, this is an experiment done. Can you see how fast the gas is pressurized? It releases Hmm? The pressure on a PV breaker, it burns, and of course this is an animation of liquid. Hmm? And now the liquid is going down, turning into vapor. Okay? Because it is going out. Watch it. Watch it, the sharpness, how they're flying. And there may be no warning for it. Okay, folks? So, let's come back to. Do you have a clear idea? Any question so far? Come on, don't be hesitant. Okay.
So it is carried at, sir, about -161, 160.
Yeah, that is a cryogenic temperature. Okay, and it is of course released when. So there will be some heat ingress from sea and outside environment. Mm. And of course, latest ship with modern installation have a boil-off rate of about just 0.1% of a day. Okay, so LNG carriers, which are the carrier about 40 to 50,000 cubic meter loaded condition, they have got around 0.23 per day, on ballast 0.13 per day. But that may not be sometime enough for your consumption. So you will have to create your own vapor. Okay, so so LNG carrier about 135,000 cubic meter. This is the barge we are talking about, or a lower level vessel. This has got 0.15% and 0.08%. Now you noticed that the bigger the ship, the lesser the boil off. Okay, remember the spherical tank has got less boil off because less surface area. The bigger the surface area, the greater the boil off. Okay, so yeah,
Family way. And we have a difference between loaded boil off and on ballast boil off.
yeah. This is just to give you an idea how much boil off is available. That boil off is also dependent on the surface area, because the boil off only happens from the molecules on the surface. Okay. Yeah.
So is it because the draft is different? That's why the boil off rate is different.
Yes. Normally, if you want to keep the on a membrane tank, it is in a straight tank in a heel condition. If you keep the ship trim and keep the liquid right near the trellis at the back, it is very little boil off. But if you make it even keel, and even if you vibrate the ship a little, then the boil off is going to increase a lot. So if you, as a chief engineer, you are short of boil off, just ask the captain to bring the ship to even keel, and ask him in the middle of ocean, stop for a minute and give an stern movement. That is what I have done when I was in command, to just give a little stern movement, vibration for 2-3 minutes, and you will have so much of pressure in the engine room you really cannot handle it. So the boil off gas is not a problem. You don't need to run your forcing vaporizers or your compressors, so many and all that. Okay. Hmm? So then NBOG requirement is the means are to be provided to maintain tank pressure below Mars. You know, a maximum allowable relief valve setting. Okay, by safety utilizing of disposing of bog natural boil off gas at all time while in port, while maneuvering, while standing. So the MARF setting, is there to we do not want our tank to be damaged, isn't it? Do you agree? So normally we will maintain that, and we'll use the boil off if of course the pressure is unbearable. We are allowed to jettison the cargo, or we never go that route. We normally take it back, reliquefy, and throw it back in the tank because it is all money. We are not allowed to do any um, um, environmental damage. VOCs controls and all that. Methane is not a good idea to send it to environment. Although roughly 18 tons of methane is being created by the cows only. Yeah, it is. That is why in India we produce the carbon gas, and we throw it and we put a cover, and sometimes we call it biogas. Yeah, biogas. Isn't it? So actually it is methane from the carbon. So whenever the cows are farting, they are just and very strange thing which I've learned just last week in a meeting or in a conference that
a lot of methane is
no, I mean not from the back end of the cow, the front end of the cow is also produced.
yeah.
There are some very funny videos on it.
During urination, even when they breathe.
I mean birds or something like that. I don't know, to be honest. I'm not a cow specialist. But anyway, so they are doing enough damage to the environment, so we shouldn't do any more to it. So it is our job. If every single mole of hydrocarbon need to be treated, recycled or reliquefied and consumed if need to be, because rather than sending CH4 into the environment, we rather turn it into something useful and energy.
So otherwise it causes what? Ozone layer?
No. It damages the environment. It is we have got the emissions controls nowadays, ECA rules, that emissions control, and we want to cap the um, carbon emissions in the global, because you're hearing about the global warming and all that. So it is, we want to reduce the nitrogen oxides, we want to reduce carbon dioxides or carbon oxides, and also we want to reduce the particulate matter and sulfur. We are also keeping the good thing about LNG, it has virtually zero SOx, no sulfur, because we filter it in the process. NOx, yes. If you engineers not, maintaining your engine in the right position, or right um, oxygen and fuel mixture, or keeping the temperature of engine high or exhaust temperature high, you might have a high level of NOx. So NOx is a variable thing, but of course NOx are lesser as compared to the marine gas oil. And of course particulate matter is virtually zero. Carbon emissions, because methane has only one carbon atom, then it is fairly low. You can expect it. Okay. So what we are saying here, maintain tank's pressure below maximum allowable relief valve setting, and not to become liquid for a period of 15 days. So that is the sustainability we should have in the tanks. Okay. Can I move on? Okay. Now, this another thing which I'm also telling here, and this is courtesy to Wardzilla. It is their bunker station picture, because we are talking about LNG bunkering, LNG ships, LNG bunker barges. Technically, this is how they connect it. I'm going to show you a small video, and this is where you will be able to see me. We have courtesy to Viking Grace. We have visited the Viking Grace for this project, and they have kindly given us for this project viewing only their bunkering process. Okay, so bunker station requirement, because you'll also see it here. Sufficient natural ventilation, physical separation and structural protection, stainless steel cryogenic drip trays, class A60 protection, vapor return line provision, manifold filters, manual and remote ESD valves, emergency shutdown valves, ESD valve closing speed, which need to be about 20 seconds on average. We are doing it. ESD on bonding connections, remote control and monitoring, local pressure gauges, drainage and purging, inerting provision, gas detection and enclosed, semi-enclosed bunker station, ventilation and gas detection of enclosed bunkering lines, and fixed fire detection and extinguishing system. So, folks, while we are on this bunker thing, because you will be taking bunker and you will be consuming the vapor at that time. That's why this is also, for example, the video which I'm showing you, it's a Viking Grace, and they do not have a vapor return line. The bunker barge gives the liquid to the ship, and now the vapor in the tank, which is now pushed up, the engineers manage their own vapor. Okay, so just bear with me for a second, and I'll put on the other video. This is the vessel Viking Grace. Okay, and they have got these two types of tank, bullet tanks.
Oh, it's a cruise.
Yes, it is a cruise line, and roll on, roll off cruise liner. It is a. I have sailed on this vessel, courtesy to them. I mean, the whole group of our project has done the sailing. So for you engineers, this is what they have got. These are Wardzilla engines, 4, and this is the electrical unit. They are generating the power from it, and from there, of course, they have got dual fuel boilers, ABB generator, propulsion system, and GCP unit. Now this is the actual bunkering process going on. See, what they have done is now earthing, and they have started the water outside, the water curtain. This is the AGA Linde bunking barge coming alongside. And when it is coming alongside, you will see they have a very small water curtain type thing going on. They are taking, can you see the personal protective equipment they have got there? This is the bunkering station. This is a very well ventilated station. Okay, they have passed the lines. This is the breakaway coupling, which I'll talk to you later. In the middle, this is what they are now connecting. Only the liquid line is going to be connected. Now they do a leak test, and now the sea gas, which is the bunker barge, will do the pressure test, and then of course will cool the line. Okay, that line. Now you see the cooling line has happened, and now if everything is okay, he has given okay, give us the liquid LNG, which is 100% transfer rate, and then now people will evacuate this. There is not a single mole leakage. All you are seeing, they have put a stainless steel drip tray. Can you see it under that? Of course, it is bunkered for not very long, and and this is only video monitored. And
no one stays in the manifold watch.
No. There is manifold watch, but you know it is through cameras. Because if this pipe burst, it is going to burn you. You know. So now closing of ESD valves and manual valve both. Okay. Now purging the manifold with nitrogen. Now the C gas will give either this thing or purge the line with the nitrogen. So there is no hydrocarbon in the line. It is all gone. C gas will retrieve its bunker, and they have a storage position over there. These folks will secure and blank off and flush off the rest of the thing. And of course now this is a watertight door which is now closed, and now the manifold is again inerted back. So there is no gas in this thing. So whole gas now has gone to the tank at the back. So 6:30 the barge has arrived. Now you can see 7:30 the barge is leaving within 1 hour, and they have done hundreds of operations so far. So this was technically the first bunkering barge, which was of course converted from an a kind of ro-ro vessel to this bunker barge, and Viking Grace was the first passenger barge to the. It runs from where we have gone. It is from Turku. Turku to Stockholm, and from there to Sweden, and it is on a daily run from there. So they do the bunkering 6 times a day. Sorry, 6 times a week, and of course they have their holiday, but the ship runs for 7 days. So happy? Any questions about bunkering?
Quite interesting.
Quite interesting.
It's just like any other, loading on the LNG.
Yeah, it is very simple. But the difference here, when we were, doing the exercises yesterday, we were giving the vapor to shore, or we were reliquefying the vapor. But this here, the engineers on this vessel are combusting the vapor in their engines, or managing the vapor. If the vapor is too much, they cannot consume it. Of course, they will convert it to liquefy it and put it there. But mind that reliquefaction is cost, money, power, isn't it? Because it is not a straightforward reliquefaction. It is a cascade refrigeration. Have you learned about cascade refrigeration? No? What you're learning in engineering, folks. It's a shame. It's a double stage refrigeration. I'll do it if I get time with you, special. Maybe in the evening. Okay, the cascade refrigeration. Okay. So anyway, so this is what the requirements are. So now many ships we have got GCU. GCUs are simple gas combustion units. Okay? GCU is the unit which there are so many, because nowadays we do not want to waste a single drop of energy. Earlier on, you may have seen some 20-30 years back, we have got, when we were used to navigate the ship, in the ocean, coastal areas, there are so many flares burning everywhere. Nowadays, touch wood, those flares have come down. or very hardly we see, because we have understand the importance of energy. So nowadays, if we have got excessive boil of gas, we can even heat it, mm, run the boiler, convert that energy to electrical energy, run generators and store it in batteries, or you know, or use it in some other fashion. So uh, other than your electrical power generation, so that is all, So, but main GCUs are only used on the big ships or big plants where we have got too much of gas coming in and we cannot re-liquefy it, so we burn it rather than throwing the gas. So, capacity need to establish capacity for intended service. So normally, we these are the boilers we have got. We create steam from it, and we use steam energy. This is the uh, your boil of gas unit on a ship of about 35,000 cubic. It's a big boil of unit. So what we are getting, the LNG booster pump we are running, giving it to boil of gas condenser and LNG to vaporization system. Okay, so or compressed boil of gas is coming and we are consuming it here, or LNG from storage facility is coming to this vessel, and we are sending all of them to the so this is where we are converting the liquid to the vapor. This is the most important valve. This is at the point of interface between the deck and the engine room. Because this is the only pipe from which the hydrocarbon is going to the engine room. Okay. Yes, of course, there is no non-return system. Nothing can go from engine room to deck. So even if you try to put in hot air back to deck, you cannot do that. So whenever yesterday we have done day before yesterday, we have done the emergency shutdowns. So in that we have that thing closing down. So this is also one of the valves which close on activation of emergency shutdown. So emergency shutdown, if that thing is happening, then if you are dependent on the gas from the deck, because we want to isolate in case of fire and in case of emergency the engine room and deck. And so this you will have to be very smart to take, start or can shift your diesel generators to the dual fuel generators to diesel power generation. Of course, nowadays I was surprised that the the engines which were on Viking Grace, they were Wurzel engines, and they were able to transfer from gas to diesel or vice versa in the blink of eye. Literally in the blink of eye. So, the on a graph, we have a graph recording. It was just a spike coming down and starting again. It is like a UPS, uninterrupted power supply kind of thing. So the technology is improving, folks, and the sky is the limit at the moment. So this project is giving you just the fruit for thought and also the basic knowledge to work further. Okay? Any questions so far? Okay? So this valve need to be open for supply. And also one more thing. Later we'll talk about the LNG cargo calculation. So once we are doing the LNG cargo calculation, this valve need to be closed when we are doing the survey. What is on the deck? How much you have consumed? Are you getting me? So this is a natural boil off, very simply, and this is what you will do on the simulator now. in the exercise. You will run the small pump. Um, um, we call it a stripping pump or whatever you want to call it. Give it to the spray header, okay, and get it sprayed and take it back. Or you can also do one thing, is that you take the vapor, separate the liquid and the gas, put it in a low duty compressor, LD compressor, then pass it to LDH, heavy duty heater, Logan, Glasgow, here. Okay, and then give it to boiler, and this is where the interface is for this. Okay, so that is in the ballast voyage, and in the loaded voyage, you can do the same thing, but in a loaded voyage you have got so much of liquid that you can even give it to the forcing vaporizer for this thing. No, this is okay. It's not. So the lecture was not recorded? Recorded. We started at 9 o'clock and I don't know if it is recorded. Recorded. Okay. So, and then it is going there. I will show you on different ships on these simulators. This is the spraying during the ballast voyage. We can take the liquid, okay, from the tank. We can take the liquid. You have seen that, and of course, when we throw the liquid back into the tank through the spray nozzles, and when it is spraying, it is automatically converting to gas, or at least vapor. That will have a mixture of liquid and gas, and we suck those. Mind that we cannot send the gas to the engine room unless it is plus 25 degrees centigrade. So, different companies have different policies, but on average, it is plus 25. So we will have to pull the gas liquid, vaporize it, and then heat it to give it to the engine. Okay, that is the whole process is boil-off management.
So there's some ambiguity going between the industry that should they have more ships with the reliquefaction plants, or should they not have ships with the reliquefaction plants because of the commercial aspects. So what do you think? Are the reliquefying ships better than the...
Yes, always. We do not want any of the VOCs, volatile organic compounds, going into the environment. We need nowadays the industry is going to zero tolerance to emissions. So the new generation of the ships are made with all these things, even for because now, as I have explained you on the first day, that this parity between the prices of LNG oil has dropped so much that the difference of benefit between these two are not big at the moment. So of course LNG pack is a big money investment, but even these companies which are making these ships, a new ship, say container or bulk carrier, they are making it as an LNG ready ships. Means there is a space, there is other arrangement, piping arrangement or design already there. The only thing, whenever it is the right time, they will put it in there. Like exactly like putting a CNG, converting your car to CNG in India, Pakistan, Bangladesh, and all these countries. We are converting a lot of cars to CNG. So if there is a space for a cylinder, you can convert it, isn't it? Just the small kit, and it will be converted. So very similar to that. This is the element. So reliquefaction is a good idea, but again, for reliquefaction, there is a carbon footprint. You are consuming energy to reliquefy it, isn't it? And bringing something which is, in a vapor state or in a gas state, removing so much of latent heat from it, and changing its state to liquid back again, it is amount of energy. So if there, number one thing, we need to have the best insulation to reduce the boil off, isn't it? And that is what the industry is doing. And you have seen very little insulation, 0.08. So which is negligible. In fact, you need much more than that to consume. So the good thing about these all LNG ships which are run on LNG fuel carrier, who are running it. Mind that there are some of the Q-Flex, Q-Max models are not consuming LNG, and all their boil off, they are just using gas oil and diesel oil. They do not have this. So they have the GCUs, gas combustion units, to burn it. But where they are just generating the heat, which they will use for different things on board the ships. And sometime if the boil off is too much, they will just do steam dumping. Do you know steam dumping? Yeah. Just giving the hot water bath to the fish, which is also not right. Because you are damaging the ecosystem.
So steam dumping is not good, okay.
Isn't it? Is it a good idea to give through the hot water and very hot water into the sea? Although we do it. Excuse me. So, that is not a good idea. Especially when you are not getting any economical benefit or energy benefit from that process. If you burn it in the boilers and the steam you generate, you run something with that. That's good. Even the steam turbine to create some maybe running your refrigeration system on it or running an electrical plant with it. It is okay. Are you getting me? So the LNG pumping, boil off gas pumping, is very simply, we use the pump, we give it to the LNG vaporizer. From the LNG vaporizer, we will just heat it and give it to the system. You can see condensate from the boil of gas or from LNG cargo tank. Why we are calling it condensate? Because it is kind of in between, So temperature minus 160, but the pressure is this. We convert the pressure to about this, and temperature 45 plus minus. Okay? So this is high pressure gas to the engine. Of course, you need it to be injected with the because nowadays you may be aware of the SI engines. Have you heard of? No.
Electronic engines.
No, SI, spark ignition engines. Spark ignition engine and compression engines. Those engines. Yeah. So these dual fuels engines are also spark. Some of the engines are spark ignition. And the good thing about them, they could be medium speed and high speed diesel, with reduction gears on it. So let's move on, folks. So boil off gas to the engine room, natural boil off, natural boil off, very simply, going to the boilers. Yes, boilers we do not want to feed at very low temperature, but it is a good idea to, So this is your engine room bulkhead, and this is the point where we need the boil off gas valve. Okay, and of course there is an exhaust fan if in an emergency we can, jettison the cargo. In between, before you cannot give to the boiler or engine a gas which is very cold or in a condensate form, not in a full vapor form. We need to convert it to 100% vapor. So this is now all this need to be done with a force. So the compressors are required. So those compressors are small compressors, LD compressor, low duty compressor. And that is not your normal compressor, they are piston compressor. They are just vanes. And then of course we have got the whole system where if we do not have the liquid vapor coming to us, we will create we will start the pump, spray pump, about 300 kPa liquid at -161 degree. We are giving it to the vaporizer, heat it to about certain temperature, and then we give it to anything above -160, it will automatically turn to vapor or gas, and then we are going into the compressors, and this is going into happy.
Spray pump is the same as
it's a cryogenic pump. It is inside the tank, and it is a very small pump as compared to the main cargo pump. I'll show you. There are pictures. So any other questions?
We were talking about
this
pump,
is
what do you call stripping pump.
Yeah. Spray pump or stripping pump are the same thing. Same thing. Yeah, we call it a stripping pump because when we are doing the cargo operation, we use it as a stripping pump. But for our consumption purposes, we do not require big quantities, isn't it? We rather have small, reasonable quantities. Okay, and of course it's an EcoBoat system where we are not using the compressors and using the forcing vaporizer just to push it to the system. So this is
fleet management.
Yes. So this is a fleet management courtesy to them, and of course very simple curve.
But they don't have LNG ships.
They are working.
They recently got this Varun ships, but they are disaster ships. But they have got a Tech 8 for now LNG and LPG.
I cannot comment on any companies, so I'm not allowed to do that.
Yeah, but it seems like there's a lot of research on it.
Yes. LNG, we call it a fuel of future. That is why we have got so much LNG bunkering going on. And port of La Spezia is arranging bunkering. Barcelona port, we have learned just on this end of September, I've learned they are making arrangement. Ravitosa, isn't it? They are also. Ravitosa is also in Greece. They are. Yeah.
It's an import terminal LNG in Greece.
Yeah, it's an import terminal, but they are arranging for LNG bunkering also.
Yeah, I think so.
Yeah.
I'm not sure about it.
But I mean, there is so much of work. There are so many bunker ports now, or bunker barges now who are provided. And about, I think, couple of hundred ships are on this,
Skitimat is having, I think this year, next year, they should have this LNG bunkering and LNG terminal on.
Yeah. So, I mean, it is, and we are thankful to all these companies who are, putting their efforts, and it is something for you to learn as a learner, So, boil off gas utilization management, this is this is how you are doing, using the compressors, heaters, feeding your dual fuel engines, and this is alternators are running, and your propulsions are going. Okay, happy? So very, very simple process. So our job is to feed these beasts. Okay, and whatever the emissions they will create will be comparatively less as compared to burning the heavy fuel oil or diesel oil. Okay. So diesel electric propulsion system, this is what actually the Viking Grace has got. This is a Wärtsilä system which they were using, and of course they have got different gearboxes to converters, etc., etc. This is the mist separator, which I have shown you earlier, the picture of it, and of course it is the forcing boil-off gas inlet. Means when forcing boil-off gas is coming, it is coming under pressure. Okay, and because we are using the compressors. But natural gas boil-off is not under compressor, so it removes the mist or condensate from it, and of course we will put it outside for further heating and sending it to. So thanks to Wärtsilä. This is what because we have done quite a bit of work on Wärtsilä. Wärtsilä is our partners in this project, isn't it?
That is.
Wärtsilä is our partners in this project, isn't it? Or they have
not like partners.
They are supporters.
Yeah, they supporters. They helped us with the visit that we did in public areas. They gave us their technical knowledge, both in Baltic areas and in our conference before a month here in Glasgow. That they sent us a technical manager as a lecturer for a very interesting about an hour about the state of the art, what they did in dual fuel engines and how the market is going the last years about dual fuel engines and all the systems that had to do with the LNG fuel ships. So yeah, they assist us a lot.
Because you are a student of this project, so we can share with you some of the conference presentation. So you will be beneficiaries of this lab. So, and this is dual fuel electric, which is using natural boil-off or forced boil-off. This is what they have got: dual fuel electric, also natural boil-off, and two-stroke diesel engine plus reliquefaction plant for HFO. Natural boil-off steam turbine getting low and low. This is, you can see. So this is just giving you the different how the industry is using the gas. Now we'll come back to IGC code. Everything we are doing is we are always referring to IGC code. This is where this is the key code for us, International Gas Carrier Code or gas code, or unless of course IGC code is a part of SOLAS. Unless an alternative means of control, the pressure and temperature is provided, a standby unit affording a spare capacity at least equal to the largest single unit should be provided. Okay, so a standby unit is also required. Means if you have got too much of water, then all right, you should have an span more or less equal capacities. You can also burn the boil of gas. Regarding reliquefaction, you need very large plants. They are complex, of course, because I've told you it is a cascade refrigeration cycle we will go through. It is expensive, of course, it will cost money. And of course, no second unit is practical. When it is not practical, then we'll go for a reliquefaction. And of course, alternative means are also required. So This is also one of the system where we, thanks to Hamworthy, who has produced this information for and of course this is an Hamworthy unit which is using the gas and of course nitrogen reservoirs and just self-explanatory where you can boil off gases, feed and run and cool it water. Okay, so I'm not going into the detail of it. We also have a thermal oxidizer nowadays, which is gas. It is also a Saki gas combustion unit. Courtesy to them, we are using their picture and acknowledging them for that. So this is now fitted on here. Can you see here? This is where it is fitted, and of course it is a dilution of cooling air, primary combustion air, secondary combustion air, and this is what it is used. Okay, over there for this unit, and this does not require a lot of space. Our objective here is to make the planet greener. Our past generation, currently we are doing too much of carbon emissions. That is why, or the emission, not only carbon, the other emissions also. We need to control them, otherwise we will destroy this planet. This planet will not be livable. That's why the European Union is investing money to find the alternatives, and one of the alternatives is of course LNG or LNG fueling. So this is just a very small thing. The whole GCO for this vessel, and of course it is fairly Now there is one more problem which is called a rollover problem. Rollover problem is not too much on our ships, because we already do the rolling and pitching. This is a bit of a menace for shore tank, but there was some incidents recorded on a big LNG carriers when they are standing by on anchorage or standing by on port for longer time, their cargo has rolled over. So how does it roll over happens? This is evaporation always happens from the top. Okay, and once it is happening, mind that LNG is the combination of ethane, methane, propane, butane, and all these things. Of course, methane is the biggest part of it, 96, above 90. So, but what will happen? That from the top, the methane will evaporate. And when the methane will evaporate, the top layer will become heavier, which will have more moles of ethane, propane, butane, etc. It becomes heavier and it roll over. It fall down. It fall down because the evaporation slows down from the top, because all the methane molecules has gone. And now there is heavier molecule which need more heating. For example, propane boiling point is around in the region of -50. Butane is around minus nearly zero, just above that. So we do not want it to be. They do not want to evaporate, so they become heavier. And suddenly, what happens in a rollover position? They just roll over at the bottom. The denser thing tries to go down, and suddenly we will have a rapid, because now the fresh methane will come over, and it starts, create so much of vapor, and sometimes this vapor is not manageable. So you as an engineer need to be ready if that could happen. Or the other method is just to recycle. create some, convection current, just recycle it within the tank. So, the cargo is on a homogeneous cargo. Okay. So, are we happy? This could happen on your ship if you are using a bunker tank with the cargo, and most of the time, if you are using you are not forcing, you are using the vapor from the tank, spraying and using. So the top layer and whatever remaining there would be heavier. Have you ever used the LPG or propane butane cylinders?
Yes, sir.
Have you used it?
I get cold.
What about you?
Yes.
You have used it. Okay. Um, if the cylinder is empty, uh, have you ever shake it? Hmm? And you feel like there is some sand inside,
Yeah.
and they are hydrates, the heavier condensate, and it is like sand. So that is kept on building. So you as an engineer should try to keep the whole thing as homogeneous as possible and try to consume it all, rather than partial consumption of just pure methane molecules. Otherwise, you will also have a problem that when in combustion, when you are burning something from the bottom, you will get less methane molecules and more of other impurities, ethane, propane, butane molecules. So, when weathering rollover, a small amount of LNG boil-off is generated by heat and gas through a tank insulation. Liquid on the top layer evaporates, cools, and becomes denser. This is known as weathering. Okay. Heating of lower layers results in equilibrium of densities of two layers. When this occurs, the interface between the layers breaks down, resulting in rapid transfer of heat and mass within the tank. The two layers mix rapidly, and lower layer, which has been superheated, gives off large amount of vapor and rises. This phenomena is called rollover. So I have explained you this whole lot. So you are happy with it? Any questions with regard to rollover? So it is your job as an engineer to maintain it. So this is just a boil off and weathering effect. This is becoming heavier. Suddenly it goes down. The other liquid comes up, and this is a very nice, and density. And of course, this is pure tank. This is the thermal image. Any questions, folks? No? Wonderful. So I'll just bear with me for a second. I'll show you another video of it.